everyone, I hope you are doing well at home. Welcome to today's lesson, which is differentiation. It is lesson 2. We are going to look at the equations of tangents and normals to a curve. So remember the first lesson we learned how to differentiate to get a gradient function. Now we are going to use it to get the equation of a tangent and to get the equation of a normal. So look at my board. I have an equation of a curve y is equal to x cubed plus 2x plus 1. I want to find the equation of a tangent and a normal I want to find the equation of a tangent and a normal to this curve at this point. Remember, the point has to be given and it is very specific. It is 1 and 4. So I want to make a rough sketch of this curve. So let's curve. Now the equation is y is equal to x cubed plus 2x plus 1. Now we want to get the equation of a tangent of this curve at this point, and this point is 1, 4. You remember in our last lesson we learned how to get the gradient function. Now, what is a tangent? A tangent is a line that touches the curve only once at that particular point. So we are supposed to get the equation of this tangent. So the first thing that we need to do is to get the gradient of this tangent. And how do we get the gradient of this tangent? We will get the gradient of this curve at this point. So remember, you have y is equal to x cubed plus 2x plus 1. For us to get the gradient function, we will differentiate this. So we'll have dy dx is going to be 3x squared plus 2. Remember, when you differentiate one, it's a function, it becomes 0. So this is the gradient function. So at this particular point, 1, 4, the gradient is going to be equal to 3 times the value of what x is 1, so it's going to be 1 squared plus 2, and this is going to be 5. So at this point, the gradient of the curve is 5, and because this curve is touching the tangent, so it means the gradient of the tangent also has to be 5. So here I'll have the gradient of the tangent at that point to be equal to 5. So if I may draw that line, if this is the line, that is the tangent, the gradient of this tangent is 5, and the coordinates, one of the coordinates of that tangent is 1, 4. So we want to use this gradient and this coordinate to get the equation of that tangent. So you remember, we take another point which is x, y. So we write the coordinates now 1, 4, x, y, and then the gradient is 5. Remember how we get the gradient using the 2 points. It is y minus 4 over x minus 1. I equate this one to 5. So I'll multiply this side by x minus 1, this one by x minus 1. So this will cancel. I have y minus 4 is equal to 5x minus 5. So y will be equal to 5x minus 1. Because when you take 4 to the other side, it's going to be negative 5 plus 4, which is negative 1. So this is the equation. This is the equation of the tangent. So we are finished with the first part of the equation. The next part is to get the equation of the normal. So what about the normal? You remember what we call a normal? A normal to the tangent, it makes 90 degrees. So this is what we call the normal. So it is normal, it is making 90 degrees at this point. So in this case, we have the tangent, then we have the normal. This is the normal, this is the tangent. Remember, they are intersecting at a common point, which is 1, 4. 1, 4. And the gradient of this tangent, we got it, is 5. And we have got its equation, of course. So the question is, can we get the gradient of this normal? The answer is yes. Remember what we learned earlier on is when we have two lines that are at 90, that they are meeting at right angles, they are meeting at 90 degrees. It means the gradient of the normal and the gradient of the tangent, when you multiply them, the answer is -1. You remember m1 times m2, the answer is -1. So m1 is for the tangent and m2 is for the normal. So you remember m1 for the tangent is 5 times m2, the answer is going to be -1. So m2, it's going to be -1, 1 over 5. That is going to be the gradient, that is m2, that is the gradient of the normal. So if I draw that normal again, you remember it is passing through at a certain point, which is 1, 4, and then now the gradient, it's also passing through another point that I'm going to pick, x, y. The gradient of this, remember, it is -1 over 5. So I'll say now y minus 4 over x minus 1 is equal to -1 over 5. Then I will multiply both sides by x minus 1. I multiply this one by x minus 1 also, so that I can cancel this and that. So that I have y minus 4 is equal to, I open that bracket, it's going to be -1 over 5x plus 1 over 5. If I take 4 to the other side, it's going to be y is equals to -1 over 5x plus 4 and 1 over 5. So this is the gradient of, this is the equation of the normal. So this is the equation of the normal. So I have satisfied the requirement of the equation. I have got the equation of the tangent, of which I got it here, and I have also got the equation of the normal, which I've got here. That is how we can get. We are going to look at example 2 very fast so that we can be able to wind up this lesson. So my second example is you find the equation of the tangent and the normal of y is equal to x cubed minus 2x minus 1, and at this point 1 -2. So I will draw that, the tangent at this point, 1 and -2. This is the tangent and this one is the normal. So I will start with the tangent. To get the gradient of the tangent, I have to get the gradient function of that curve at that point. So x cubed minus 2x minus 1. So my dy dx of this, it's going to be 3x squared minus 2. So the gradient, it is going to be 3, because it is at this point, it's going to be 3 into the value of x at that point is 1 squared minus 2, and this is going to be 1. The gradient is going to be 1. So that tangent, it is going to be to pass through 1, -2, and the gradient is equal to 1. So I guess another point that is x, y. So you have y minus -2, so it's going to be y plus 2 over x minus 1 is equal to 1. So I multiply this side by x minus 1. Then I multiply this side by x minus 1. So I'll cancel. So I have y plus 2 is equal to x minus 1. And y is going to be x minus 3. Because if I take 2 to the other side, it's going to be -1 minus 2, which is going to be -3. This is the equation for the tangent. Then for the normal, very fast, you remember this is our normal. it is passing through the point 1, negative 2. You can be able to see it is passing through 1, negative 2. And also I can say it is passing through xy. Remember, we said m1 times m2 is equal to negative 1. Our m1 for the tangent is, we found it to be 1. So 1 times m2 is going to be negative 1. So that means m2 is going to be negative 1. So m2 is the gradient for this normal. So the gradient I can say is negative 1. So I can proceed to get the equation and say y plus 2, because y minus negative 2 is going to be y plus 2 over x minus 1. I equate this one to negative 1. So I multiply this side by x minus 1, this one by x minus 1, so that I can cancel this. So y plus 2 is equal to negative x plus 1, and y is going to be negative x minus 1. This is the equation for the normal. So that's how we can be able to find the equation of the normal and the equation of the tangent. Have a good day. I hope you have enjoyed today's lesson.